welcome to 24 Hours of Past Preview Edition and Alex Whittles' session on Beginner's Guide to MDX. So, I'd like to just give you a quick note about technical assistance. Alex, do you mind hitting the slide there? So, for example, if you have questions about or need technical assistance, just shoot them to me in the questions window, and I'll be happy to get back to you and give you a hand. I'd also like to take a moment to thank our sponsors, Microsoft, Idera, Dell, our presenting software sponsors, and SQL Sentry, HP, and Pyramid Analytics, our supporting sponsors. So I hope you're all planning on attending the PASS Summit this year. It's going to be amazing. There will be a lot of really good speakers just like Alex there. It's right now, you can get $200 off with the discount code 24HOP15. What you'll get there is over 190 technical sessions from some of the best SQL Server presenters out there. All right, and in addition to 24 Hours Past, we also have a whole bunch of events, SQL Saturdays, which are local to your region and area, virtual chapters, local chapters, and just tons and tons of great content. Now, I'd like to take a quick moment here to introduce Alex, our presenter. Alex is the owner and lead consultant at Purple Frog, a SQL Server business intelligence consultancy in the UK. He specializes in dimensional data modeling, ETL systems, OLAP cubes, Power BI, MDX, and DAX, and has an MSc, Microsoft Certification in Business Intelligence. He also runs the Birmingham, UK SQL chapter as well as the Azure user group in that area and runs the SQL Relay conference in the UK. He's a regular speaker at events such as SQL Bits and the PASS Summit, as well as numerous SQL PASS chapters around Europe. And without further ado, Alex.
Great. Thank you very much, Brandon. And very good morning, good afternoon, or good evening to all of the attendees, especially if you're pulling the early shift over in the US time zone. Appreciate the early start. Right, so today we're going to be kicking off the 24 Hours of PASS, talking about MDX, and specifically a beginner's guide to MDX, going back to basics on how the MDX language is structured and looking at how we approach understanding an MDX query. So first of all, what is MDX? Well, it's a query language, but instead of querying a normal transactional database, SQL Server, it queries OLAP cubes. I like to think of it as a bizarre hybrid of T-SQL and a Rubik's Cube, because it takes data in the cube in a Rubik's Cube style of slicing, filtering data, but applies some familiar T-SQL concepts, or at least a familiar look and feel. But despite sharing some similarities, it needs to be approached in a very, very different way, and those differences are what we're going to be looking at today. So let's take a step back and look at cubes. I'm assuming most of you have used cubes before, but let's just take a very quick high-level overview and look at how we access a cube. So a cube is a database, but is not the same structure and style as a transactional database. It's installed with SQL Server. As well as SQL Server, there's various BI components, integration services, reporting services, and analysis services. And cubes are part of the analysis services component of SQL Server. To connect to a cube, we use SQL Server Management Studio. And when we connect to an analysis service database, we connect in the same way as we do with a normal database server, but we see a slightly different icon. We see a cube icon instead of a database icon. Once we connect to a database, we can then see a list of all of our cubes in that database and all of our dimensions, measures, and everything else. So how do we go about querying the cube? Well, there's loads of tools we can use for reporting. There's starting out with Excel, which is always the starting point. You can connect Excel straight into a cube, and it will give you a pivot table, allowing you to see all of the information in the cube in a very drag and drop format. There's also reporting services and tools very similar to that, which give you a drag and drop query builder for cubes. There's also tools like Performance Point, loads of other dashboarding tools available, Power View, Queries Cubes, and tools like that. But the one thing they all have in common is they all use MDX as their underlying query. Now, as you probably know from if you've had any experience with query builders for T-SQL, they do a reasonable job. They're very good to get you going and to start off. But as soon as you want to add any kind of complexity or interesting logic, automated query builders have a lot of limitations. And so to really leverage the power of a cube, you need to understand a bit of MDX so you can start writing your own calculations and improve the performance of your queries. So let's have a look at a typical T-SQL query. So here we're querying fact internet sales from the AdventureWorks database. And the key critical component of a SQL query is what we have in the select statement. We define the columns we want to show in the report. All of the rest of the query is purely telling the database how to give us those fields. The joins and the tables aren't really important from an end user perspective. They don't care where the data comes from. They care how it's presented, and that's where the select, the list of columns on the select list defines the structure and the output structure of the query. Note that we only define the columns. We don't define what's on the rows. What comes out on the rows is dependent on whatever content happens to be in the database, and you may not know what that is. You may get one row, you may get 1,000 rows, you don't know. Now, yes, you can apply extra concepts to this, such as group by and things like that, but we're looking at the basic simplified structure of queries at this stage. If we compare that to MDX, straight away you have some similarities. You have a select statement, you have a from statement, and a where statement, but critically we define two axes rather than one. First of all, we define what we want to see on the columns of the result set, but also we define what we want to see on the rows. So we're defining a two-dimensional structure of how we want the results to appear. So straight away there's a fundamental difference in the approach to this query. So in this example, we'll look at some more detail a bit later on, but just as a high level, we start out with a select statement, and we specify something that we want on our columns, we specify something we want on our rows, we specify the cube we want it to come from, and then we can specify where clauses, which essentially act as a filter, albeit in a very different way to T-SQL. Now, the interesting bits here are what we put in these areas here. Now, this is where a lot of confusion comes with MDX because of the terminology and naming conventions of cubes. So that structure is when we want to define what we want to see on our columns and rows, we have to define a set. When we specify a where clause, we have to specify a tuple. And there's all these different naming conventions in a cube. There's members, there's dimensions, there's measures, there's sets, there's tuples, there's members, etc. And if we're not clear on those naming conventions and what all these different names mean and how they're referred to, it makes life very, very difficult to actually understand what an MDX query is doing and how it's going to work. So on that basis, this is the main area we're going to be looking at today, is looking at this terminology and looking at how it actually represents itself in a cube and what the difference between a set, a member, and a tuple are when we look at queries and how we structure those. Now, I started out by drawing some comparisons to T-SQL. It's dangerous to do that because they are fundamentally different languages, and if you try and take a T-SQL query and convert it into MDX, it will almost certainly fail because you have to approach it with a very, very different mindset. Having said that, when trying to understand the terminology, it can be beneficial to compare it to an equivalent concept in T-SQL. And so that's why I've created this cheat sheet. which aims to highlight the high-level comparisons of concepts between the two different systems. And this cheat sheet will be in the slides available for download on the 24Hop website. And if you are struggling with MDX or want to get more into MDX, have a printout of this on your desk, and it can be quite a useful guide just to clarify what's going on. Now, the reason a lot of people struggle with MDX is because of confusion between these terms. So what we're going to do now is take a step back through to each of these terms and look at what they actually mean and how they're represented and how we define those in our query. And if you get to take any MDX query that you're struggling with, go back to basics, boil it down to its simplest components using what we talk about today, and you should get some clarity as to why it's not working or what's not working properly for you. So let's start out with the star schema, the structure of measures or fact tables and dimensions in our cube. We start out with our measures in the middle. Those are our numbers, our facts and figures we want to report on. Then all of our dimensions around the outside, our slices, filters, customer, product, date, those kind of things. So if we look at a dimension, most of the complexities in an MDX query revolve around dimensions and how we slice and dice and filter those. So that's where we're going to be focusing on. So if we look at a dimension, we can think of a dimension, a customer dimension, for example, to be equivalent to a customer table in a SQL Server database. Within that SQL Server customer table, we have a number of columns: customer ID or customer key, customer name, customer address, date of birth, these kind of things. Each one of those is equivalent to a cube attribute. It's essentially a column. It's a particular field that we're looking at that contains data. Within T-SQL, every table has a number of rows. The equivalent in a cube is a member. It's a particular value. Now the difference here is that in a table, a row contains every single column. It's a complete set of data for that one particular customer. In a cube, it's not. It's a single value of a single column or a single attribute in cube language. So we can break our table into columns and rows. In a cube, we break our dimension into attributes and members, or columns and rows. We can then take multiple members. So if we think of a member as being, for example, a single customer name in the customer column of the customer dimension, a set would be multiple of those. So we may have multiple customer names, or in the date dimension, we may have today's date and yesterday's date. The critical thing with a set is that it has to be multiple members of the same attribute or the same column. You couldn't have a set containing today's date and a customer name because they come from different attributes and different dimensions. So a set has to have an identical structure. You can think of a set as equivalent to, or conceptually equivalent to, the union statement in T-SQL. You can't union two different queries with different structures. They have to be identical. So when we conceptually think of a member, we're going to use this cube visualization to do a lot of our understanding of how cubes are filtering and understanding our query. In this example, we're representing a supplier to supermarkets. In the UK, we have a number of different supermarket chains: Aldi, Waitrose, Morrison's, Asda, etc. And those are our customers on the left axis. We have our data dimension across the bottom, and then we have various products that we could sell to those supermarket chains, and those are represented on the right-hand axis. So what we see here is a representation of what happens if we select the Morrison's member of the customer dimension, specifically the customer name attribute. So we see here that by selecting Morrison's, we actually select a complete slice through the cube, all the way through. It selects every single date and every single product, because we haven't filtered those out. All we've done is select Morrison's as a single member. So we can see this is the concept of where the terminology a slice comes from in a cube. And every single one of these values is then included in our resulting data. Now when we're looking at a cube is more than likely going to have a number of different dimensions. It may have dozens and dozens of dimensions. Not many people in the world can visualize and picture a 20-dimensional cube or 20-dimensional space, apart from maybe Stephen Hawking. So what we do when we're trying to visualize our MDX is simplify the cube down to only 3 dimensions, or even 2. So here we only care about customer, date, and products. We may also have a number of other dimensions in our cube, regional manager, things like that. Anything that we can't see in this visualization is included in every single cube. So if we've got an area manager called Joe Bloggs, Joe Bloggs will actually exist in every single one of these cells. The fact that we can't see that dimension in the cube means that all of the area manager data for every single member exists in every single subcube or slice. All we're doing is ignoring any other dimensions and just focusing on the ones that we're actually reporting on. So when we refer to a member, we use a 3-point naming convention of dimension, dot attribute, dot member. So in SQL language, table, column, row. And critically, we use square brackets. Now the naming of these brackets is language and culture dependent. Every country and every language has a different naming convention for these brackets. In the UK, we call them square brackets. Whatever you call them, that's fine. So what we do is we wrap up the dimension in our square brackets, dot the attribute name, dot the member. So if we wanted, for example, the 2013 year, we would specify date.year.2013, the dates table, the year column, the 2013 value. And that's the same for any dimension. So here we're using our customer, and then the customer's country, and then the UK. Sometimes you see values repeated, customer.customer.waitrose. So this would be the customer dimension, the customer column, or the customer name essentially, and then the actual value. So in all of these examples, we're specifically selecting a single hard-coded value. But we can also use functions such as current member. Now, we'll look in this in more detail later on, but we can use things like this to make our MDX more dynamic and add quite a lot of very cool functionality. Don't worry about that for now. We'll get back to that later on. Now, instead of just looking at date.year.2013, we could also refer to it using an ampersand. Now, the ampersand, in this case, doesn't change anything. It's the same value for both. What it's actually doing is, if we don't use the ampersand, we're referring to the actual name or the value of that member. If we use an ampersand, we're referring to the underlying key. Think of that as the surrogate key in a SQL Server database. Now, in some cases, they're going to be the same, such as 2013. We would use the same value in a cube for both the year and for the key. But sometimes they're different. For example, with the month name. With month, we may give it the name of March, but a key of 3. It's the 3rd month in the year. Now, the reason we have different keys is useful for sorting data in the cube. You don't want to sort data alphabetically by month name, or you'll end up with August and April at the start of the year. So by giving it a numerical key, the cube sorts that data correctly 1 to 12. Sometimes it can make queries more simple if you refer to the number rather than the name, for example, multiple languages. However, sometimes using the key is a very bad idea. If a particular product called widget 3 happens to have a key of 5682, no one understands what 5682 is. There's no business concept there. So you should use keys very cautiously, and normally you would refer to them by name, because anyone coming to read your query is going to understand that better. There is a slight, very marginal performance improvement by using the key, but that's a trade-off with the lack of usability and readability of your query. So here we're looking at a set. Here instead of choosing a single customer, we've selected 3, Waitrose, Morrison's, and Sainsbury's. So we've created 3 different slices through the cube, And note, they don't have to be sequential. They've got gaps in the middle, that doesn't matter. As long as they are the same structure, and each one is a complete slice through, so they're fine, then a set is any number of members grouped together. Any number means 0 or infinity. You can have as many as you like. So how do we refer to a set? Well, we now use what we call the, I'm not sure what they're called in the States, brace, I think they are, the curly brackets. So we wrap up the set in these curly brackets, and then we specify all of our members in a comma delimited list. Now, this could be 0 members, it could be any number you want. So in this top example, we are creating a single set of 2 years, 2010 and 2012, as visualized in that cube there. If we replace the comma with a colon, that changes the behavior and instead creates a set of the range between these two members. So if that was the case, then this creates a set of 2010, 2011, and 12. So essentially we're including 2011 in our set at that point. Now we can use that to do some more interesting functionality in MDX, such as null colon current member. Null goes back to the start of whatever is available in our cube. In this case, it's at the start of the set, so it's the start of time, the first year we have available, which in this case is 2008. And it creates a set of everything up to the current member of the year. So this, we're in 2015, so that will create a set of 2008, 9, 10, 11, 12, 13, 14, 15. Now this dynamic behavior is useful if we wanted to create things like a running total balance of a bank account. You want to add up every single transaction from the start of time through to the current date. Well, using this kind of concept, you can create a dynamic set of whatever day you're looking at data, it will create that running total for you by putting a sum around this set. Again, we'll see an example of that later. Now moving on to the one that causes the most problems, tuples. Now whether we call them tuples or tuples, it's entirely up to you. It's the same thing, it's just down to preference, tomato, tomato. So a tuple is essentially an intersection of two different members in a cube from two different dimensions. So here we're choosing Morrison's from our customer and 2011 from our date, and we end up with this subcube here as the point of intersection. So this tuple, all it does is it says, I want Morrison's data for 2011. So you can think of this as an AND clause in a T-SQL where clause. So select star from whatever data we have, where customer equals Morrison's, and where dates.year equals 2011. Note that we're not filtering product. So we see here a square, but actually it goes right the way back through the cube and selects everything that we can't actually see in there. So every single product is still included in that cube. We're only filtering these two dimension values. So how do we refer to tuples? Well, here we get into round brackets. One thing working with MDX, you have to learn to love brackets, whether they're round, curly, or square. If you don't get your head around the brackets, MDX will give you a world of pain. As soon as you get your head around what the brackets mean and use them correctly, then all functions and functionality start to make sense. So what we're doing here is we're specifying another comma delimited list of every member that we want to include in that intersection. So in the first example here, we're doing 2012 and Waitrose, so we get that single block there. In the next one, we're including the product banana as well. So now we have 3 different dimensions being included in our tuple, and so we can see there the effect of that. And again, you can keep adding in more and more dimensions into this to narrow down the cube more and more and more, add more slices of different dimensions and attributes. I mentioned earlier that even if you want to have dozens and dozens of dimensions in your query, trying to visualize that and understand that can be very, very difficult. So get your query working with a simplified set of just 2 or 3 dimensions, make sure that works correctly, and then you can start adding in the extras, the extra dimensions and members when you're confident the actual structure of your query is correct. So here we've got this 3-member tuple of the customers Morrison's, the year's 2011, and the product is banana. So what's actually happening there is we're selecting this subcube in the middle. So let's think about what's actually inside this subcube itself. In our cube, in our measure groups, we may have dozens and dozens of different measures, calculations, and values. We may have the total sales value, the number of orders, the number of individual items. We may have the profit, the delivery, the tax, loads of different measures. They are all included in every single one of these subcubes that we're visualizing here. So every single one of those measures will be in that cell there. They will also be in that cell there, and every other cell that we can see in the cube. So what we're doing here is we're purely filtering and slicing our attributes to narrow down the selection of what business entities, dimensions we want to include in our report. But at some point we have to actually say, and now we've narrowed down our cube to that small area, now we want to see a particular measure from that subcube area. And again, we'll see an example in the demos later on. Okay, so let's jump back a bit to sets. I did lie to you earlier when I said that sets were a collection of members. They're actually not. They can go one step further than that, and they can actually be a collection of identical tuples. So in this example, we've got Sainsbury's in 2009, we've got Waitrose in 2010, and we've got Morrison's in 2011. All 3 of those tuples have identical structure. They look the same in our cube visualization. Therefore, we can combine those together in a set. So we looked at this structure earlier with the curly brackets for our sets, and then a comma delimited list of members. We could all put together in a set. And you could have as many different tuples coming down here as you wanted, and you could have as many different comma delimited members in your in each tuple, as long as every single line is the same. Now, if this was listed on one single row, it wouldn't be as intuitive and as easy to see if they have the same structure. But by putting every tuple on its own row, you can very quickly see whether the structure is correct. Laying out MDX according to these brackets can massively help you narrow down any problems in the query. Okay, that's enough slides for now. Let's get on to onto some demos and examples where hopefully that will make a little more sense in the real world. So that's the end of all the slides that we're going to be looking at. So everything now is demos all the way. Okay, so we first of all said this is our basic structure of our MDX query. So I'm going to define 2 different sets against, and this is AdventureWorks 2012 cube, but the same queries will work on any AdventureWorks cube that you can download. This demo script is available for download on the 24Hob website. There's a number of the demos that we're going to be going through today. There's also a lot more at the end that's there for an extended 2-hour session that we haven't got time to cover in today's session, but by all means do carry on going through those yourself and see some further examples of MDX functionality. So let's make a start. Let's run this first query and see what comes out. And we can see here that, there we go, that we're looking for the calendar year 2008 on our columns, and we can see there that we have calendar year 2008 coming out in our results set. We're also asking for the product dimension, the category column or the attribute, and the bikes row or member on our rows, and we can see that coming out on the rows. And we're pulling this from our AdventureWorks cube. Now, I mentioned earlier about surrogate keys, or the keys you can have with attributes. Now, I know that the bikes category has a key of 1. So in the bottom query, I've replaced product.category.1, and that should give us exactly the same value of $13.399 million, and there we go, it's exactly the same value. So that works, and technically, if all we care about is performance, that query should run a little bit faster than the first query. The problem is, if you write this query, and then someone else comes in to look at your report and sees that, will they understand what that means? How are they going to understand what the report is doing without running it? So yes, it may be technically a little bit faster, but this fully qualified name in there is a much more preferable structure to use in a query purely for maintainability, unless there is a genuine reason to use the key. Okay, so let's run this query again, and we can see that the value we're looking at here is $13.399 million. The question is, $13.399 million of what? Is this sales? Is it profit? Is it gross? Is it net? Is it product value? We have no idea. Nothing in this query gives us any indication as to what actual value that is. Now so how does the cube know to put this particular number here? And that comes from the default measure in analysis services. When you design a cube, you allocate a default measure. And if we don't specify which measure to use, that's the one that it will bring out. Is this a good or a bad thing? Well, it's a very good thing for certain bits of functionality in cubes. It is necessary to have it there. But it's very bad to use it and rely on it in this context. Because again, from a management and maintainability perspective, the next person that comes to your report will look at this and they won't have a clue what's going on. Or worse still, if someone changes the default measure in your cube, all your reports suddenly go from showing gross sales to quantity of items sold, and that could be potentially quite disastrous. So what we have to do is, once we've specified our query, we have to, and including our members or filters and slices on our columns and rows, we then have to tell the cube that within that subcube that we've filtered down and selected, which of the actual measures we want to bring out. And we do that by adding a where clause. So we can say, of that subcube that we've filtered down, of all of the data that's contained within that subcube, let's have that particular value as the one that's coming out. So if we run this, we should get exactly the same value of 13.399, and there we go, it's the same value. But at least now we know what it is we're bringing out. Okay, so in this situation we have only a single product category of bikes coming out. But we can extend this, because this is a set on our columns and rows, we can add as many different members as we like into our query. So let's run that, and we can see that now we've got bikes, accessories, clothing, and components all coming out in our results set. Note we've still only got a single value on our columns because we've still got 2008 selected, which is coming out as 2008. Now that's fine, and that works. But what if your company adds a new product category? Are you going to have to go through every single report, changing the MDX query to add the extra category in? What if the name of the category is changed from clothing to wearables or something? Any changes to the structure is going to break that report. So one of the things we try and do when writing MDX is make it more dynamic and make it self-maintaining and self-healing. So in this example, we are, instead of specifying the individual members directly, we're specifying the product dimension, the category attribute, and asking for all of the members of that attribute. So dynamically, this will give us a very, very similar data set, and it lists all of our categories without us having to specify each and every one. And if categories get added or renamed, it doesn't matter. They will still come out of that query. It's a generic query that will now adapt as the business evolves. Now, those of you that are paying attention may have noticed we've now actually got an extra member at the top, this all products. Where did that come from? That wasn't there when we specified them all individually. And this comes down to how the dimensions and members are actually structured inside our cube. When you create a dimension, for example, the date dimension, as well as having all of the attributes, year, day, month, day of week, week number, etc., you can also create user hierarchies, where we can say create a hierarchy of year, month, and date. And that would then allow users to navigate down that hierarchy, starting out at the year, click the plus, expand that out into all of the months, click the month, and expand that out into all of the days. In this case, in product category, we haven't created a hierarchy, but the cube creates one automatically for us, whether we like it or not. You can turn it off, but by default it's on. So what happens is it's a two-level hierarchy. It's all of our actual members and then an all value on top. So there's always two levels of this automatic hierarchy. So when I said to you earlier that the naming convention for dimensions, attributes, and members was a 3-point naming convention, it's actually a 4-point naming convention. This automatic hierarchy in the middle, you can skip over, but this is where it may cause a problem because it includes this all value. So if we, first of all, change the query to ask specifically for this all member, then we can do that. So all products is 9.7 there. So let's run that, and we can ask for that one single value that comes out just on its own. But if we want to remove that, instead of looking at products.category.members, we can change that, that naming convention to include an extra level in the middle. So instead of being dimension.attribute.member or members, we add an extra level in, which is dimension.hierarchy.attribute.member. So what's happening here is we're saying in a product dimension, look for our category column or attribute, which would include the all value. But instead of asking for all of those members, we jump down to the actual attribute itself inside the hierarchy and then ask for all of those members. So just by adding in that extra stage, we remove that all member from the query, which is now gone. Now, using this 4-point naming convention, you can very easily get a situation where, let's say we had an attribute called product, which was a product name. You could end up with something like this, where you see product.products.products.members, which looks utterly stupid until you understand what all the different parts of it mean: dimension, hierarchy, attribute, value. Let's change that back. Okay. Okay, so we now have, here we go. So here we're still looking at a single year on our columns, which comes out as 2008. Oops, sorry. What if we want to have multiple years? So let's now change our set to include this colon, which gives us a range of everything from 2006 to 2008. And we're not changing anything else in our cube. So now we suddenly have a number of different years displayed in our result set. Okay, so let's filter this further. If you think about this going back to our cube visualization with all the different dimensions on it, we're filtering by two different dimensions, the year and the product category. We're not adding any other dimensions into the mix. So let's say we want to keep that as our filter, but so that determines the columns and rows that we're seeing in our structure. So anything in the columns and rows here defines the shape, the look and feel of this query. But what if we want to change the values of each one of these cells to filter that down further? We want to include only a certain type of these orders, but without changing the rows and columns. Well, we do that by adding extra filters or extra members into the where clause tuple. So here we've got our round bracket there. Well, that indicates this is a tuple. So we can keep comma delimiting more and more members in our where clause to filter the data that we're seeing. So what this query will do is, instead of showing all of our sales, so here, for example, accessories for 2008 is $407,000. What we're going to do is we're going to filter that to say, well, we only want the sales that were made in UK pound sterling. So we've got a dimension called source currency. So I'm going to add, and source currency is the currency that was used to purchase that particular order. So I'm going to add GBP or UK pounds into the where clause tuple, and note the size and structure of that result set is not going to change, but that value of $407,000 should be reduced, and we can now see it's gone down to $40,000 instead. So the structure's the same, but we've changed which values, which records essentially have been included in that value. Okay. Now, in the AdventureWorks cube, we don't just have a source currency. We also have what's called a destination currency, which is a reporting currency. Note that even though we've filtered by Great British pounds, all of the results set still comes out in dollars, and the dollar sign's included in the results query. By adding in the destination currency, we're not necessarily filtering the data, but we're applying extra logic that's included inside our cube. So I've added on here a destination currency of GBP into our where clause tuple. Now again, this is not going to change the size and structure of our result set, but it will change what the makeup of each of these individual numbers. So let's run that, and we can see that $40,000 is now showing as £26,000. That's the same data. We're not filtering the data, we're just applying extra logic. There is logic built into this destination currency dimension that alters the behavior of how the data in the cube is presented. Not only is it doing the currency conversion, but it's also changing the display format to use the pound sign. So cubes aren't just there for simplicity of getting data, for drag and drop, and for query performance. They're also very, very useful for applying some very complex business logic, such as currency conversions. What we're going to do now is change the structure of our query and put destination currency members on our columns. And so we can see, again, just for our orders purchased in GBP, so that same data, but we're now going to see all of our currencies listed in this result set. So the sales made in the first column are exactly the same sales reported in the second column, and exactly the same column sales reported in that column, or Canadian dollars, or in euros, French francs. The same sales are being reported multiple times, but in each column it's just using a different currency conversion. Now, if you try and do that in T-SQL, you're likely to be there for quite some time. Doing this in MDX, once you've built that logic inside your cube, it is incredibly simple to apply that same business logic and that same complexity to every single report that you have. Notice not also the currency conversion, but also the formatting and stylization of the numbers as well. So all of your applications that query your cube can then inherit the same formatting. Now, when we talked about tuples earlier, which are these round brackets, we said that it was a comma delimited list of members from different dimensions. Well, here we're seeing measures.internet sales amount in our tuple. Now measures isn't specifically a dimension, it's a measure group. But when we're writing MDX, we can use measures as a dimension. So we can use functions like .members to see a list of all of our measures in the cube. So if I do this and say, okay, well, let's define a tuple on our columns of bikes 2008 and ask for every single measure on our rows, we can see every measure that's available in our cube. Now this isn't particularly useful for reporting purposes, but it's very, very useful for testing purposes. When you want to test every single measure in your cube, then this is a very easy way of taking a full data dump and then comparing it to the same query yesterday. And we use that quite a lot for daily testing and exception reporting. Now here we get something different where we're asking for all the members of our measures. You will also see a function called allMembers. Now members on its own is all of the raw members that naturally exist in your cube. But in your cube you can add calculated members as well, calculations and expressions. And by putting all members instead, that will then also include your calculated members as well. Okay, so we can then say, let's create a set of our measures on our columns, internet sales amount and internet order quantity. So what this does is it gives us a set of our measures on our columns. Now you look at this query and you think that's probably going to be easier to write that in T-SQL. Select some of that, comma some of that from this table, group by product category. And yes, it probably would be easier to write that in T-SQL. But in T-SQL, how would you pivot that to put product categories on the columns and measures on your rows? That becomes very, very difficult. But in MDX, we can simply change these around. So you get much more flexibility of how you write your query. You can also be incredibly lazy. Instead of writing rows and columns, you can put axis 0 and axis 1. It'll do exactly the same thing. So even though a particular query may be easier to write initially in T-SQL, think of the flexibility that you can get by using MDX and whether you may benefit from that in the future. Right, so note in this query, we also have empty values. So in our components, there are no sales. So we may want to strip these out and only return data with actual values. So we can use the NonEmpty function to strip out these empty values. What we're saying here is we want to report all of our product categories where the internet sales amount has a value. And so by running that, we can then strip out the column we don't want. Now there's also another way of writing NonEmpty, and that's non-space empty, that you put outside of the set curly brackets. Now in this first version, you have to specify which measure you want to use as the NonEmpty test. Even if there is data for order quantity or reseller sales amount, they will not be shown in this report because we're using the internet sales amount as our NonEmpty criteria. If we use non-space empty, then it will look at the rest of the query and say, any measures that we're bringing out, let's check them all, and let's see if any of them come out. So in this case, the query is looking at both of these two and saying, there is no data for the components, therefore don't show it. But if we bring on the reseller sales amount into our query as well, then we know there is reseller sales amount data for components, and so suddenly that row is now showing us data. So using non-space empty is usually a better option. It's also an important thing to note in interviews. It's quite a common interview question. What's the difference between non-empty and non-empty? And there you go. Okay, so I think we're out of time to go through the rest of go through any more demos at this point. There's obviously a lot more demos and calculations and things like that we go to in the demo scripts that's available for download. But at this point, I'd like to do a quick summary of where what we've covered in in this session, and then we'll get to any questions if there are any. So the key takeaway is you must think in MDX. Don't try and translate a query from SQL to MDX because the structure is inherently different. It's absolutely vital to really get it clear in your head the difference between a member, a set, and a tuple, especially in the naming conventions, the round bracket, the square bracket, the curly brackets. And also write generic queries. Write a query that's going to still work in 5 years' time after you've left the job. Someone else is maintaining your queries. Make sure they're going to be able to understand your queries and functionality. And critically, use MDX for what it's good at. Don't try and write audit reports, 100-page reports in MDX. MDX and cubes are there for high-level aggregate reporting. So use them for that functionality. If you want a query that's better off written in T-SQL, use T-SQL. Don't think you have to use MDX for everything. Make that call yourself as to which one is going to be most appropriate for your requirements. If you want to know more about MDX, well, I still think one of the best books that you can get, even though it's 15 years old now, is Fast Track to MDX, which was co-written by Moshe Pasheminski, who actually wrote and created the MDX language when he was at Microsoft. It's out of print, but I think you can still buy it on Amazon from some resellers. TechniTrain runs some fantastic multi-day MDX courses, primarily in the UK. I'm not sure if they do any outside. There are also websites like MD Expert, which are great resources on functions, what different MDX functions do. There's a tool called MDX Studio, which helps you build MDX queries, gives you a kind of execution plan essentially for MDX queries and can be quite useful. And then, of course, there's blogs. There's a multitude of blogs all over the internet with some very, very valuable information, including my own, which is purplefrogsystems.com/blog. If you have any questions on anything in this session or anything else cube related, then more than happy to answer questions on there. So we do have some time left for questions. So do we have any in the list, Brandon?
Not right now. We actually, you just answered the last one from Neil. Oh, here's one that came in. Is there any windowing functionality analog for that running balance example of member and interval?
Okay, so windowing functions, not directly, because there isn't really a concept of rows coming out of the query in MDX. Every cell is treated individually. But I can show you a quick example of something that gives you that similar functionality with actually the next example that I wasn't going to go into. But we saw earlier the current member functionality. If we were to write a calculation that was year-on-year growth, we can say take the internet sales amount of the previous year. So that gives you that relative ability to hop backwards and forwards in rows. So if I run that, what we're doing is we're saying when we're calculating this particular percentage, this minus 2.1, it's taking the value from 2008 for bikes and comparing it to the previous year's value and then using the two to come up with a percentage growth. And so you can use these prev member, current member style functionality to navigate up and down in your dimension. And that's why it's also critical to sort and order your dimension members correctly to make this kind of functionality work. So there is no direct replacement for windowing functions because MDX has a far more powerful set of functionality like that by using these kind of current and prev member functions. Hopefully that answers that question.
Okay, we've got a few more coming in now. So someone is asking, how does DAX relate to MDX?
Okay, chalk and cheese. DAX has a lot of very similar functionality to MDX. In some cases it has more functionality, but in some cases it has less. It is a very, very different structure. In the same way that you can't convert a T-SQL query into MDX, you wouldn't want to convert an MDX query into DAX. Because of the tabular model's design and functionality, it is inherently different in the way that you go about writing queries. So although you can achieve a very similar thing, it's a very different mindset. And so migrating and switching from MDX to DAX can be a little tricky switching between the two because of the different mindsets. So there isn't really much in the way of comparison, although you can do the same functionality with them. In terms of the current member, prev member, it's a different approach, but it has the similar kind of thing you can do with it.
So a follow-up for that, which one is better for reporting?
What's better, a pint of beer or a good glass of wine? Depends on the situation. We have clients using both cubes. Some clients use both at the same time. Neither is better than the other. It depends on your specific requirements. We've got some clients who have actually migrated from tabular back to multidimensional because of it offers more functionality for their particular use case, and some clients we've migrated from multidimensional across to tabular. There is no single right answer as to which one is better. It is entirely dependent on what functionality you want, but also where your skills are. If you're a DAX guru, use DAX. If you're an MDX guru, use MDX. We use both. Which one's better? They're both great. They're both far more powerful than T-SQL, and we use them both interchangeably, so learn them both, I would say.
Okay, so someone writes, I don't understand why you write something like customers.customers or product.category.category. Why not just state it once?
Because of the different naming, the different meanings of those different names. So if we jump back to that relevant slide, we can see, let's go to here. So you may have a customer dimension. In that customer dimension, you may have a customer name attribute. So customer.customer_name.Tesco. Sometimes they're called the same thing. This, although it's the same name, customer.customer, they are totally different things. This is the table, essentially, and this is the column. So in your T-SQL database, you may have a customer table, and in that table, you may have a customer column. You couldn't use those two interchangeably, even though they have the same name. They are fundamentally different concepts. The first one is the dimension, or the table. The second one is the attribute, or the column. And so you have to specify it twice in order for it to work. Otherwise, it would be the same as in a SQL Server where clause saying where dbo.customer equals Waitrose. Well, that wouldn't work because you're not specifying a column there. You need to say where dbo.customer name equals Waitrose. And so one of the things with MDX is don't try and fight it. You need to specify the 3-point naming convention. Don't fight it, just give into it and work with it, and it will work with you. Hopefully that answers that question.
All right, well, we've got exactly 2 minutes left. So I want to thank everyone for attending and thank Alex for his time and wonderful presentation. Up next, we've actually got testing with your data your way from Melody Zacharias. I know Melody, she's awesome. Stick around for her session next. And thank you all again for attending. And hopefully I'll see you at Summit.
Yep, and thank you from me for all attending, and thank you to Brandon for moderating as well. So have a great rest of 24 Hop.
All right, I've ended the